Morning. And all of a sudden it's Thursday. I was waiting for the rain to stop last night and it just kept on coming and I fell asleep. If you ever have any questions about the universe, right?
The next of my introductory astronomy lectures. We've finally left all the stars behind and now we're going out and looking at the entire universe as a whole. So this begins the series of lectures on galaxies, the larger universe, and the Big Bang, the origin and fate of the universe. So let's start off with a cosmic address. And first we're going to define what we mean by the concept of cosmology, which is what we're going to be talking about for the next bunch of things. Cosmology is an area of physics, it's an area of astronomy, but it's its own separate thing, and it's the study of the entire universe as a whole. So we're looking at all the physics of the entire universe, how things are distributed on all size scales, how things move about inside the universe, such as galaxies and space and time itself, and how the universe itself evolves with time. And then we're going to be talking about, finally, as we go through this long series of lectures, the age, origin, and fate of the universe. And that's...
I mean, it's all there, isn't it? So many people. There's so much stuff about the universe. Everybody knows everything about the universe. But the truth is, nobody knows anything about the universe at all, right? It's just horseradish after horseradish after horseradish. Right, here's my quick take. I've got so many things I wanted to do, and it rained yesterday. I had all these things, right? So now I'm a bit, where do we start? So I'm going to cover two things this morning. Alexa, how many times has the Parker Solar Probe orbited the Sun?
From Gizmodo.com. To date, the Parker Solar Probe has completed 7 orbits around the Sun.
Parker Solar Probe. Caught me off guard. It's out there doing the stuff. The Parker Solar Probe. Launched in 2018, all right? So we just heard there, 7 orbits so far. It's getting closer and closer. So like ever decreasing circles. Quick flyby of Venus, take a few happy snaps, get some data. Orbits. Orbits of Sun. 7. All right? Alexa, how many times has the Parker Solar Probe orbited the Sun?
From Insider.com. Since it launched in August 2018, the Parker Solar Probe has rocketed around the Sun 3 times,
3 times.
Getting closer than any spacecraft before it and travelling faster than any other human-made object in history.
7 times, 3 times. Alexa, how many times did you say the Parker Solar Probe has orbited the Sun?
From GitHub.com. Orbited the Sun 21 times.
Alexa, how many times has the Parker Solar Probe orbited the Sun up until now?
From Gizmodo.com. To date, the Parker Solar Probe has completed 7 orbits around the Sun.
So we'll give the 7 another tick. We'll come back to that. All right. What do we have here? We have a Sun. Let's get a little bit closer because you're not going to be able to see it from there. So I've drawn a Sun, and on the Sun I've got little markers. 1, 2, 3, 4.6. Then after, from the edge of the Sun, we've got 1, 2, 3, 4, and then there's a tiny planet Earth, and that's 4.6. And then I've done one more. 1, 2, 3, 4.6. Now I think anybody who's been following my shenanigans knows exactly what the 4.6 is. It's the 4.6 seconds that it takes for the sun to radiate light the distance of its own diameter, because according to the speed of light, which is allegedly 299,792 kilometers per second, if we divide the diameter of the sun by the speed of light, we get 4.6. Alexa, what is 1,390,000 divided by 299,792?
1,390,000 divided by 299,792 is approximately 4.6365.
So that means it takes 4.6 seconds at the speed of light for the sun to radiate light the distance of its own diameter. What I've done, as we know, the sun's diameter is 1,390,000. So I wanted to do Earth and the sun to scale, because it needs to be to scale. If you're doing something like this, if you don't have things to scale, you can give the totally wrong impression, can't you? You can trick people, fool people, but when things are in proportion, it just gives a clearer, more accurate, honest, truthful picture. 1,390,000. What I could have done is made the sun 1 meter and 39 centimeters on here, right? So it would have been double the size. Then I would have made Earth 1.2 centimeters. So this would have been twice the size. But what I did to bring it down to scale, divided the 1,390,000 by 2, which gave me 695,000. I then divided, because what you do to one, you must do to the other to keep things in proportion to each other. I divided the diameter of Earth by 2, and we get 6,371 kilometers instead of the 12,000. So right now, they're both together, they're both in scale. 695,000, I made that 69.5 centimeters, right? 30 centimeter ruler, 0 there, 60, 69 and a bit. Close enough for what we're doing. The Earth at 6,371 becomes 6.37 millimeters, because that is 695 millimeters, right? 69 centimeters. So what we have here is a planet Earth. It's just over, right? It's probably about 7 millimeters, right? And the other one's the same. So planet Earth and the sun are now to scale. When you see these little diagrams and little pictures come up on social media, there's a massive sun, and then they put planet Earth, and you've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. And it says, this is the sun, you are insignificant because you are so small compared to it. That is the right size when comparing Earth to the sun. It's to scale. So why have I done this? Hang on. Alexa, how many times has the Parker Solar Probe orbited the sun to date?
From Gizmodo.com.
7 again, I
To
think.
date, the Parker Solar Probe has completed 7 orbits around the sun.
Alexa, did you say that the Parker Solar Probe has orbited the sun 7 times up until now?
From Gizmodo.com.
7.
To date, the Parker Solar Probe has completed 7 orbits around the sun.
We'll come back to that. So we've had 7, 3, and 21 so far, okay? Alexa, what is the Parker Solar Probe's overall mission?
According to an Alexa Answers contributor, the Parker Space Probe is a solar probe set to reach the sun in 2025. Its mission is to measure the sun's corona as to better understand the inner workings of the sun and the solar wind.
Okay, didn't give us a number. All right, we'll get back to it. So why have I done this? For me, the light of the sun and the stars is absolute, all right? I think it's a slam dunk, right? I have slam dunked this before. But according to scientists and academia, the speed of light is 299,792 kilometers per second. Reasons to not believe this. First of all, old Roma in 1676 was the first person to have anything to do with working out the speed of light. It's obviously horseradish, because nobody in 1676 would even have a reason to want to measure the speed of light, because this was 200 years before electricity. There was no bulbs, no torches, no batteries, nothing electric. So why on earth would anybody suddenly decide they wanted to work out the speed of light? This in itself is illogical, it makes no sense. But at the end of the day, with Olaus Roma, he took his observations of Io coming out from behind Jupiter with a telescope. Whether you like to believe this or not, a telescope would not pick up any light delay. Been over this, I don't know how many times. It wouldn't matter if there was 10 people, right, in Earth's orbit around the sun in 10 different places. If all of those 10 people were observing Jupiter waiting for Io to come out from behind Jupiter, they would all see it at the exact same time. So even if there was a delay, the telescope would have taken that out of the equation. So Roma falls flat on his face. So that is the first person, they call it the cornerstone, the first one who attempted to measure the speed of light. So everything that came after him is because of him. But it didn't happen, right? It's obvious it didn't happen because he was using a telescope. Then we've got Wheatstone, we've got Bradley, James Bradley, was it 1728, who discovered aberration, right? He discovered the parallax, how to use the parallax angle to work out the distance to the stars. He also discovered, apparently by accident, that the Earth tilts on its axis. Now, how did he find that out in 1728 when it takes 40-something thousand years for the Earth to do a full tilt and come back? But he just happened to stumble across the parallax angle, aberration. No, it's impossible. These claims are ridiculous, right? It does not happen. And then we get all the way back down to Fizeau in 1849 or 1850, a beam of light. This is the whole, when we start spinning the mirrors to work out the speed of light, all of it is rubbish, right? They can't even replicate those things today. But Fizeau, he had a beam of light, right, that traveled from where he was, 8 kilometers, right? It bounced off of a mirror, came all the way back to him, which is 16 kilometers, and this beam of light landed on the tooth of a spinning wheel, right? Now, what kind of beam of light would there have been that could travel 16 kilometers, right, when there was no power? They had the sun, and they had naked flames, kerosene lamps, oil lamps, paraffin lamps. Those were the only lights they had. So again, how did Fizeau manage to get a beam of light to travel 16 kilometers in 1849 or 1850, before electricity was a thing? That in itself, whether you like to accept it or not, is impossible, right? It did not happen. Show us how it was done. See, these are the things. People say to me, where's your evidence? Where's your evidence? How do you show evidence of somebody not doing something if they didn't do it, right? Where is the evidence that there is a beam of light that doesn't need electricity that can accurately travel 16 kilometers and land on the tooth of a spinning wheel, right? Absurdities. But people, you embrace the absurdities, don't you? Right? Right, the reason we've done this, the light coming from the stars and from the sun is absolute. right? It's instant. There is no delay. It's illogical. We've got Earth at one sun's diameter away from the sun, right? Obviously, it's not. The sun is 109 sun diameters away from the sun, right? But for this exercise, I just wanted Earth close up. I've got one sun diameter in between Earth there, and then there's one more sun diameter in between the next Earth that I've penciled in, chalked in. This is what would happen according to them and the 299,792 kilometers per second. That is the current ludicrous speed of light. They say that if somebody was on planet Earth from where we are, looking at the sun now at a distance of 150 million kilometers from it, and it was out, it was off, and it suddenly switched on, we would not see the sun for 8 minutes and 20 seconds. The reason for this is because it takes 4.6 seconds for the sunlight to travel the distance of its own diameter. And because it's 150 million kilometers away, it takes 500 seconds, all right? So that's 4.6 for every sun diameter. There are 109 sun diameters. Alexa, what's 109 multiplied by 4.6?
109 times 4.6 is 501.4.
500 seconds, right? That is 8 minutes and 20 seconds. This is where the 8 minutes and 20 seconds comes from. This is why it takes 8 minutes and 20 seconds, because it takes the sun 4.6 seconds to radiate light the distance of its own diameter, which is, I wish I could swear right now, but it's horseradish, right? It defies common sense and it defies logic. So this is what would happen if the sun was off and there was a planet Earth and everybody was looking towards the sun, but it was off. Where is it? Where is it? And it suddenly switched on. Nobody would see a thing or feel a thing for 4 seconds, 4.6 seconds. This is what would happen. And on. 1, 2, 3, 4.6. This is to scale. Earth and the sun, right? One sun diameter away. Let's concentrate on the second one. This is what would happen because they say the same. It doesn't matter where you are in relation to the sun with the current speed of light. You will not see a single thing if it's switched on for 4.6 seconds for each sun diameter that you are away from the sun. So here's what would happen. It's all to scale. We've got Earth, 2 diameters from the sun, 2 sun diameters from the sun. This is what would happen if it was dark and everybody was waiting for it to switch on. You'd have people looking at the sun from there, people looking in the general direction of the sun from there, waiting for it to light up. And 3, 2, 1, light up. 1, 2, 3, 4.6. Now this people on here would go, yay, it's lit up, we can see the sun now. And it would carry on. 1, 2, 3, 4.6. After 9.2 seconds, the second planet Earth would see the sunlight, right? It's ridiculous. It's ridiculous. If you look up at the night sky, you can pick out Proxima Centauri at 4.2 light years away, right? Like this. Bang. Your eyes lock onto the star. There is no waiting for any light to propagate and to reach our eyesight, because our eyesight goes directly to the source, right? This is a slam dunk. There is no waiting. Our eyesight can see anything in the night sky if it's bright enough. We've got Cassiopeia, That's 16,308 light years away. Alexa, what is the furthest distance that humans can see in the night sky?
Here are a few movies playing near Bundaberg today.
Alexa, stop. Alexa, what is the furthest distance? Alexa, what is the furthest distance that humans can see in the night sky?
Here are a few movies playing
Alexa,
near Bundaberg.
what is the furthest distance that humans can see in the night sky?
Here are a few movies playing near Bundaberg.
Alexa! Alexa, if I look up in the night sky, what is the furthest that I can see?
According to an Alexa Answers contributor, the farthest a human can see with the naked eye is 16,308 light years. If you look up on a clear night and find the star B762 Cas in the constellation Cassiopeia, you are seeing the furthest star visible to humans.
Planet Earth, right? Let's just say this is Cassiopeia. 16,000 light years away. You can see it in an instant. Boom, right? She's saying that's the furthest that we can see. The only reason it's the furthest we can see is because this particular star is bright enough to radiate its light to where we can see it, where our eyesight can pick it up. Look, the chances that any of the stars are exactly the amount of light years that these people keep telling us they are, it's a coin flip. How do they know, right? I'm serious. How do they know? How did anybody measure the distance to the sun? Alexa, who first measured the distance from Earth to the sun?
From Socratic.org, the ancient Greek Aristarchus calculated the distance between the Earth and the Sun in around 300 BC.
How? How? That's what she says, but how? But everybody just presumes, don't they? How? In 300 years BC, did anybody look up at the sun and go, I think it's X amount of kilometers away? First of all, there was no kilometers or miles or any kind of measuring system that far back. How does anybody look up at the sun and go, I reckon it's 150 million kilometers away? These are the questions that people are so oblivious to, but everybody just accepts, right? The only reason that we can see as far as 16,000 light years away is because Cassiopeia, that's how bright it is. If there was another star twice as powerful as Cassiopeia, right? Twice as big, twice as luminous, would we not see 32,000 light years away? Our eyesight, when we look up at the night sky, there is no limit, right? Our eyesight is infinite. All it needs is a light. It doesn't matter how far away it is. If a light shines, we see it in the night sky. It's absolute. Our eyesight is absolute. We are seeing the light that's radiating from a star 16,000 light years away. It doesn't take 16,000 years for it to reach Earth. We go to it, our eyesight. If I go like this, and it's night time, right, and a supernova goes off 200 million kilometers away, right? I see it instantly. There's no delay, right? It lights up. We see it. If somebody flashes a lighter, right, from a couple of kilometers away, got a lighter in here somewhere, right? It's dark. You're in a desert or something, right? And there's nothing. It's cloudy. It's pitch black, right? And somebody's 2 kilometers away and you're on the flat. It's pitch black. Somebody goes like this. You see it instantly. If you're looking in that direction, it's like a beacon, right? There is no delay. It's illogical. It's illogical. More than illogical to think that when when there's a full eclipse of the sun and the moon is directly in front of the sun, right? I don't even know what the word is for this. And you can see the outline of the sun, but the moon is bang in front of it, right? So all you see is the edges of the sun behind it. They're trying to tell people, right, that the sun isn't actually where it seems to be. They're saying that the sun in real life has already moved at 8 minutes and 20 seconds away from where it seems to be behind the moon. That's garbage. How can people fall for this stuff, right? The sun, its light is absolute. You see it where it is. There's no evidence for this. So why are people so caught up in it? How can you not see, right, that the sun is in the sky where it's at, that there is no 8 minutes and 20-second delay? The light is absolute, right? Where's your evidence? Where's your evidence? It's freaking common sense, isn't it? Right? The reason for the speed of light being 299,792 kilometers per second, they needed it to be that speed, because otherwise they have no power over the age of the universe, the age of the stars, the age of this, the age of the other. Because if everything is absolute, nobody knows a thing about this universe. And that is the truth. We don't know how old this universe is. All this 13.8 billion years, where did it all come from? All this relativity. Your head is aging faster than your feet because you're closer to gravity. The further you are away from gravity, the faster you age. Relativity, it's horseradish. Oh no, the evidence, it was proven by 2 atomic clocks in 1971. Between the both of them, they were something like 200 and something billionths of a second out. Please give me a break, right? This speed was needed to take control of the universe around us, right? Because if the true speed of the stars and the sun gets out, all of it is over. Relativity is gone. The age of the universe is gone. All of the lies telling us about black holes this, galaxies colliding over there, gamma rays coming out of some black hole over there. Every time they look in one of those space telescopes, they're not seeing into the past, right? We're not living in a fairy tale. They see what is happening right now. Telescopes aren't magic. They don't look into the past. You can't see into the past. We live in a present state, always, right? If you've got a family member that has legged it as fast as they could to, let's say, Proxima Centauri, right? They're not 5.2 years in the past. If you had a phone that could reach them, you'd be talking to each other in the present, right? There is no time warping and gravity bending space continuum going on. It's illogical. There is no evidence for it. All of the evidence, right? It's presumptions. All of this stuff, all of these theories, everything that they tell us, right? How come humanity is still hung up on this stuff? 1772, Joseph Lagrange, the three-body theory, that the James Webb Space Telescope happens to find itself now hovering, right? Taking all these happy snaps. Are we sure that's happening? Right? We've got Olaus Roma, 1676. 1880, the light bulb, electricity, 1880. It's when it truly cranked up, right? So what on earth is Olaus Roma doing in 1676, trying to work out the speed of light by observing Io come from behind Jupiter, sometimes up to 1 billion kilometers away from us? He didn't do it. He was using a telescope anyway, so it's really quite silly. It's a childish mistake to make. So whoever came up with this made a big boo-boo, because with a telescope, there is no light delay detected. That's if there is a light delay, which there isn't, because the light that's radiating from our sun is absolute. You've got an eclipse coming up in America, work it out. Some of you get a telescope, some of you with the naked eye, just see. If those of you who look with a telescope see the sun 8 minutes and 20 seconds further away from where it seems to be, you know what? To believe this, right, to believe these things that they keep saying, it's actually smashing against people's logical thought training, your common sense, right? Because it's ridiculous. It's the same as believing that the Egyptians built the pyramids, knowing that they weigh the equivalent weight of 65 Nimitz-class aircraft carriers. But people still hang on to this illogical stuff. The Egyptians had nothing to do with the pyramids. The end. It's obvious. So why do people hold on to this belief that they did? You need to start trusting your own judgment is what needs to happen, right? Christian Huygens, 1674, 206 years before electricity was a thing. But he comes up with the wave theory of light. All he had was naked flames and the sun. How does anybody come up with a theory like that 200 years before electricity? Why? Why is he even looking at the light? Honestly, these things are absurdities. All of them are absurdities. But to see them, I guess you'd have to think for yourself and stop believing the illogical stuff that's being taught, right? And it is illogical. What else is there? I mean, just all of them, right? Kepler, 1609. He's working out that planets are in elliptical orbits. How on earth does anyone, right, it doesn't matter the year, in one place on Earth work out, looking up at the night sky, that the planets are in elliptical orbits around the sun, right? Nobody asks these questions. How do you do it? How would anyone do it? It can't be done. Is that a guinea pig? Yeah, it is. Sorry, I just got distracted there for a second. Galileo Galilei, right? They say that back in the day, when is it? 1610, one of the first things he did was get two assistants. Well, that story changes, it's got 80 versions as well. He got two assistants to go on two opposing hilltops, 2 miles apart, 3 miles apart, 8 miles apart. We don't know. The story changes every time you ask. And he got them to, to open one of the shutters of one of the lamps. And when the first assistant opened it, the other assistant was then, when he sees it, was supposed to open it so that the light would bounce back. You know, he opens it, I see it. If Galileo is who they say he was, he wouldn't have even attempted that, because he would have been intelligent enough to know that light can't be measured. So it's an insult to people's intelligence and to Galileo's intelligence, if he really did exist, to think that after all of the discoveries that he actually made, that he would be thick enough, right, to get two assistants to stand on opposite hilltops with lanterns trying to work out the speed of light. It's ridiculous. And if he did all of that other stuff that he did, it wouldn't have even been a thought in his head, because he would be far too intelligent for something like that. So which is it, right? Honestly, the stuff that people are believing, right? The stuff that they have dumbed humanity down to believe in, it's unbelievable. It really is. Not to mention, in 1969 to 1972, 6 successful landings, yeah? 6 moon missions. 6. I mean, for the last 50 years, we haven't seen one, have we? Artemis has been trying its heart out for 3 years, still haven't even got a guy off of the ground. But they did 6, didn't they? What else have we had? Oh, we've had 60 plus flights on Mars. By remote control helicopter. Doable? Of course not. But we believe it, don't we, eh? 60 plus flights didn't topple over. Really? What else have we had? DART. Boom. Asteroid. They shot an asteroid, right? They said they'd do it. We've got no need to worry about asteroids. We can knock them off course. Really? The most bizarre thing about that one is they had a camera. They released a camera, right? And it followed 2 days behind. They released it 2 days behind the impact. And this camera actually caught stills when the missile or whatever it was hit the asteroid. Seriously, right? Seriously? They can't get shots of them landing on the moon. We have to see animated cartoon pictures, right? But they get a shot of a rocket smashing into an asteroid millions of kilometers away. I don't know what the words are. And we've got those. What is the next crazy thing? A probe that's approached to within 10 sun diameters of the sun, and it's just going around getting data or whatever. Got caught up in a coronal mass ejection, and it's filming the blast coming from the sun at a distance of just 7, 8, 9 sun diameters from the sun. The same sun is knocking satellites out of the sky at a distance of 150 million kilometers. We've got that thing up there, 10 million kilometers away from the sun, and it's swerving in and out of solar rays, taking pictures and sending them back to Earth, sending images back to Earth from within the solar fury, right? What happened to the electromagnetic force from the sun that knocks things out? They must be some serious carbon plates. These things are ridiculous, right? They are absolutely ridiculous. I think that's going to cover it for about now. We'll be back. Oh no, hang on. Alexa, how many times has the solar probe, the Parker Solar Probe, orbited the sun to date?
The sun takes about 225 million.
Alexa, how many times has the Parker Solar Probe orbited the sun to date?
The sun takes about 225
Alexa,
million years.
How many times has the Parker Solar Probe orbited the sun?
Here is an answer from an Alexa Answers contributor that I translated. 65,099,234 times.
Let's write it down. We'll just go for the 65 million, yeah? We don't need to do all the little tiny bits. 65 million times. Alexa, the Parker Solar Probe, how many times has it orbited the sun so far?
From Gizmodo.com.
7.
To date, the Parker Solar Probe has completed 7 orbits around the sun.
Alexa, has the Parker Solar Probe orbited the sun 17 times? I don't know.
From Genius.com. Since its launch on August 12, 2018, the probe has orbited the sun 17 times and is expected to continue operating until 2025.
17 times. So which one is it? You've heard it. She said 7, then 3, then 21, and now it's 17. I've gotten up to 6, 2 more different answers, right? just asking her these questions. How on earth is it even possible? This has got to be classed as AI, right? The beginnings of AI. If you've got a question, you ask. Which one is it? How do you find the correct answer? This is the horseradish that humanity is up against. And you want artificial intelligence to come in. All right, 40 minutes, holy smokes. I'll be back with some more truth later on.